I'm just going to show you how easy it is to get up and running with the SimplAR helper class. So here's the folder SimplAR, and it's been checked out from my Google code repository, and there'll be a link to that on my blog, on the blog post that goes with this this video. So if I open this folder, you'll see that this is all the stuff. It's basically a Flash Builder project. There's some other stuff in there as well, like a PDF with the patterns in there, the markers that you need to print out, and these are the data files for those patterns. So we've got the source file, that's the source folder that's got all the ActionScript classes in. The SWC folder has a couple of SWCs in, one for the FLARToolkit itself, that's the Alchemy branch of the FLARToolkit, and one here, that's all the paper vision code, that's version 2.1 revision 942, that's the subversion revision number. I just put it in there because it's much easier to get set up with that way, but of course you can point it at your paper vision source code folders if you've actually got those on your computer, but if you don't need it, they're all there ready for you. Some other assets in there, and obviously bin debug is where all your Swifts get compiled into, but let me just show you how to actually import that into your Flash Builder workspace. So if you right click on Package Explorer and click Import, then open General, Existing Projects into Workspace. I'm sure you're familiar with this process if you're used to Flash Builder. So then we actually navigate to that folder that's the SimplAR folder, which is within the Google code repository. It's like at the top level, I believe, in the trunk. Choose that folder, then you'll see that it finds that project. We'll click. You can also choose to copy the projects into your workspace if you want to. I probably won't do that right now, but it doesn't matter, you can if you want. So I click Finish, and that's our project all set up, ready to go. You can see that it's using the Swig folder there, and we've got the source folders here. And the default application is actually the SimplAR base class itself, which actually you can run by itself. It just has the, I'm just waiting for Flash Builder to catch up, it just has a simple kind of test cube and plain. So let's just see that running. Ignore that, don't want to see that again. Wait for Flash Builder to do its thing. Okay, good. Right, so now you can see we've got that up and running. It doesn't do anything when it loses the marker at this stage, but we'll show you how to change that later. I should also mention there's, if you're always getting the allow webcam requester coming up when you're trying to debug this stuff, obviously that's really annoying. So if you want to get rid of that from happening, right click on the Flash player, click Settings, and then click this little camera there. Oh no, it's not that camera one, is it? It's one of the others. Let me just check which one is it. This one. So it's the privacy settings. If you check that remember box there, then it means that it will never ask you to enable your webcam ever again while you're testing locally. So that's cool. We've got that up and running. We don't necessarily need to look at this code, but if you did want to add more complex functionality, there's you can certainly dig around there and learn how it works. But the best thing about this is that it's really easy to get up and running. So here, for example, is the simplest, well, I suppose it's a Hello World app, isn't it? But all we're doing is extending SimplAR base and creating a 3D cone, that's a paper vision object, adjusting its rotation. Now the reason we do that is by default the rotation of the FLARToolkit node and all the stuff inside it is as though the pattern marker were in a vertical upright position. So if we want things to actually sit on top of that marker when it's sat down on the desk, then you need to rotate it around the x-axis by -90 degrees. As cones are centered in the middle, and this one is 60 units high, we're going to actually push that cone back into the marker by 30 units to make sure, oh sorry, it's actually lifting it out of the marker by 30 units to make sure it sits on top of the marker and doesn't actually go through it, which looks really weird. The last thing you have to do is add your 3D object into this container object. So I explained in the intro, but container is the base FLAR node, and it's a display object 3D, a paper vision display object 3D, and anything you add into this 3D object gets updated with the position of the pattern, the fiducial pattern marker, which is great. So anything you put in here gets updated relative to that pattern marker. Just just show you the next example, SimplAR2 fading, and what this one does is actually overrides a couple of extra functions, onImageFound and onImageLost. So if you imagine what's happening in the base app, every time it goes through its enterFrame function, if it finds the pattern, it calls onImageFound, and if it can't find the pattern, it calls onImageLost. So these functions will get called every frame. So you can see on ImageFound, I'm just setting the alpha to, I'm increasing the alpha of our cone object until it gets to 1. And if the image is lost, then I'm actually decreasing the alpha of that cone. And of course, if we want to set the alpha of any PaperVision 3D object, we also need to set user own container to make sure that PaperVision creates a viewport container for that object. Let's just see that in action. So I'll just debug this. And you can see now when it finds the marker, it fades that in. When it loses it, it fades it back out again. So that's a much smoother way. But of course you can do whatever you want with that onImageFound and onImageLost. But obviously with FLARToolkit projects, you want it to kind of deal with that in a nice way. So I've put that function in there for you to override and do what you will with that. So now let's look at the next example. So obviously you're not going to want to use my seb.lee pattern marker, or lovely as it is, but it's really easy to use your own pattern markers, and here I've just included a robot smiley pattern, but obviously you can make your own as well. There's a really good pattern marker generator on Sakusha's website. It's an Air app, which is what I made all of these patterns with. So if you want to use your own pattern, then you embed it like that using the flex meta tag, and I really love this method of including these pattern data files, which I learnt off John Lindquist. A really good way of doing that, because that way it gets compiled into your Swift rather than having to load that file at runtime, so it's a lot neater. So then we've created a constructor this time for our document class, and we're calling the constructor of the parent class and passing in a reference to a new one of those pattern data objects. So that's how we've created our own pattern, our own custom pattern. So let's just take a look at that. So now it won't work with my seb.lee pattern, but it does work with this nice little robot smiley. There you go. This time we've got a sphere. Excellent. So that's about all there is to that, but now I've got a version here with DAEs, and DAEs are a little bit more complicated because you have to load them in. So I'm loading it in, and then I'm adding an event listener which tells me when that DAE is loaded. So it's not until that DAE is loaded that I set DAE useOwn container to true. And remember, DAE.useOwn container means that as PaperVision runs through the render cycle, if it hasn't already got a viewport layer for this object, it will create one. Now you can't set this useOwn container to true in the constructor up here, because at that point, there isn't actually any geometry in that DAE, so you actually will get a viewport layer without any geometry in, and it will behave really unpredictably. So to be safe, wait until the DAE is loaded and then set useOwn container to true, or set up viewport layers at that point. Then of course we're adding it into the FLARToolkit base node called container, rather confusingly, sorry about that. But that's, yeah, like I say, that's the main container, the displayObject3D, and the position of that displayObject3D is updated every frame dependent on where it finds the pattern marker. So just like before, we've got the DAE fading in and out when the image is found and lost, but we also have an enterFrame function which we're now overriding, and we're rotating that DAE around the y-axis every frame. So if you want to put something in the update function, override the enterFrame function. Let's just see how that works. So we're back to our seb.lee marker this time, and you can see there's the DAE, and it fades in and out, and the viewport layer all works, and it's also rotating every frame as well. So that's pretty much all there is to this SimplAR package. I mentioned in the intro it's got the automatic threshold adjustment as well, and there's a little demo of that in the folder. If I could probably just show you that. Look, it's here, SimplAR Auto Threshold Demo, and that's where you get to see the automatic threshold adjustment happening. But yeah, I hope you have fun with it. There's a couple of extra things that I wanted to add but didn't have time to. Like at the moment it's fixed size at 640, 480. Also, it's not possible currently to to flip the video image, although I'm sure that would be very easy to add, just something I haven't got around to doing. So if you manage to do that, let me know and I'll reintegrate it. And the other thing that I wanted to do is add a bit of smoothing onto the moving of that FLAR node. So perhaps I'll do that shortly, but I just wanted to get it out there. It's been much too long already, so it's out there. I hope you enjoy it. It's free to use, so excellent, and let me know how you get on with it.